So good afternoon everybody, myself Acharya Vishvendra. Let's discuss the photoelectric effect today. So for the first thing is observation. So it was observed by uh, scientists that when energy of photon is greater than a certain particular frequency energy, then certain photons are emitted from the surface. So this minimum energy is called the work function of that particular metal, which depends on metal and the nature of its surface, and it is called the work function or the threshold energy. So suppose this is a metal surface, photons are emitted on it and there are electrons. So this work function is minimum for cesium and maximum for platinum, which means it is easiest to take out electron from cesium, while it's the most difficult to take out electron from platinum. Now work function has the same dimension as energy and work and torque, which is ml to t minus 2. SI unit is joule or kg meter square second minus 2. Working unit is electron volt. CGS unit is erg or gram centimeter square second minus 2. Now 1 electron volt is 1.602 10 is to power minus 19 joule, and 1 joule is equal to 10 is to power 7 erg. Now the second point regarding photoelectric effect is that photoelectric effect takes place only when frequency of photon is greater than a certain minimum frequency, which we call as the threshold frequency, and it depends on metal and nature of its surface or work function. So energy should be greater than threshold frequency. That means h nu is greater than phi naught. That means nu is greater than phi naught by h, and this phi naught by h we call as nu naught. Obviously it depends on phi naught, which again depends on metal and the nature of its surface. So that's how threshold frequency is related to metal and its surface. Now let's see some graphical analysis. So we can say that threshold frequency is equal to phi by h. So graph between threshold frequency and work function is a straight line. Suppose here the slope angle is theta. So we can say that on increasing work function, threshold frequency increases, and with decrease it decreases. And for slope we can use tan theta is equal to y by x. So it's v naught by phi naught, which is 1 by h, which is a constant for all gases. And one thing is there that work function and threshold frequency is minimum for cesium and maximum for platinum. Now another case is energy greater than phi naught. So energy can also be written as hc by lambda, which is greater than phi naught. So hc by phi naught greater than lambda, that gives lambda less than or equal to hc by phi naught. We call hc by phi naught as lambda naught or the threshold frequency. So we know that lambda naught is inversely proportional to the